We're going to start off and do numbers 11 through 15 on this round. We went through electromagnets, and a lot of people did really well on the electromagnet part. Let me go through this real quick with an electromagnet. Remember, you got to have an iron core. You have to have a solenoid, which is your wire. And when you put this through here, okay? Hang on. Okay? And then we're going to hook it up to a battery. Now, and sometimes, guys, you're going to see pictures on test where they're not touching. Guys, they have to touch both ends. So when both ends touch, they make an electromagnet. And you can pick up magnetic material. Okay, so if I throw some paper clips down here and I make the connection, I'm going to be able to pick these up. But I have to make sure that the connection is happening with it and being able. Notice that there is no magnet involved in making this. I am making an electromagnet. I am making an electromagnet. There is no magnet involved. I am making it. So when they make contact, they're picking it up. Notice. See? Okay. Now, so let's go to this question here. It says a student is building an electromagnet using a battery, a coiling wire around a nail, and the student observes that the electromagnet attracts the pins. Which statement is true about this? Okay? So we can kind of look at a magnetic field is created around the electromagnet when the nail is placed next to the battery. Remember, I can put it next to it. It's not going to pick it up. It has to make connection on both ends to get electrical current. B, a magnetic field is created around the electromagnet after the battery is removed. Remember again, it's got to touch. C, a magnetic field is created around the electromagnet when the electric current flows through the wire. Or D, a magnetic field is created around the electromagnet after the pins come in contact. Well, guys, it's hard to pick these up first and then put it together, okay? You've got to have it connected whenever you're ready to do this. So our best answer is going to be C in this one, okay? This electrical current is going through these wires. And in 7th grade, you should have learned about the neutron, the electron, and the proton. The electrons, where do we get electricity from? We'll call it from the word electrons. And electricity is what is going through this wire to be able to pick this material up, okay? Number 12. Number 12 says, how can a student increase the strength of an electromagnet? Well, guys, there's two ways, pretty much, that you're going to see that you can strengthen it. You can, one, wrap more wires around. And I had a student build this one here, okay? This one here is going to be stronger than this one because it has more wraps to it, more coils, okay? Or secondly, you can add more batteries to it, or stronger batteries. Okay, that is how you can increase the strength of it. So number 12 is asking, how can the student increase the strength of an electromagnet? Is it A, by increasing the voltage of the battery, B, by decreasing the number of loops around it? So if you decrease it, you're going to have less power, okay? By switching the connection points of the battery, that has nothing to do with it, or by moving the pins closer. So the way to strengthen it again would be A, by increasing, adding more battery voltage to it. Okay, that would be your answer for number 12. Number 13. A student bounces a ball on the ground. What occurs when the ball touches the ground? So if I take a ball and I drop it, what happens to the ball? Okay? Is it A, the downward force of the ball is equal to the upward force? B, the downward force of the ball is less than the upward force? C, the downward force of the ball is greater than the upward force? D, the student cannot predict the upward force of gravity. When you drop something, it's going to have an equal force, okay? So A would be your answer for number 13, okay?
Newton's third law.
This would be Newton's third law on this one. Remember, equal and opposite force. So if it goes down, it's going to come back. So it'll be equal force. Okay?
But wait, Miss House, why does the ball not bounce all the way back up then if it has equal force?
Well, when you drop it and equal force, is there a force pushing it back? Because did I have a force coming pushing?
Oh, Miss House, are you talking about gravity? Gravity's gonna pull it down so it doesn't bounce back as high?
Exactly.
Oh,
Think of it
okay.
like this, the earth has the center of the earth is like a big magnet, okay? And the reason why you jump up is because, jump up and you come back down is because of gravitational pull. It's going to pull it back down. So yes, when you drop, there's going to not go all the way back up because the gravitational pull from the earth is pulling you back down towards the earth. That's the reason why you throw something up, it's going to come back down because of gravitational pull.
Okay.
Number 14. In question 14, guys, let me tell you right now, an element out here, as you should studied in the 7th grade, the periodic table, elements are pure substances. You cannot create an element up here. They are pure substances. They cannot change into something, okay? They are pure. So, number 14 says, an astronomer is studying the life cycle of stars, collects by the data, the composition of two different stars of similar sizes, but of different ages. Notice this one's the young star, this is the old star, okay? And the graph shows the data. This one's showing 91% hydrogen, 8 helium, 1 is of other elements. Here we have 86% hydrogen, 13% helium, 1% other elements out here, okay? So over time, you can see what's happening. This is the young star and what happens to the older star, okay? Now I'm going to read these and kind of go back to the chart here. Which argument does astronomers' data support? A, the helium gas in a star converts to hydrogen. Okay, now as it ages, remember there's no changing. We can't change into something else. B, the other elements in a star convert to hydrogen gas. Remember, we can't do something.
One element cannot change into another element. Never, ever, ever, ever.
Letter C. The amount of hydrogen gas in a star decreases. Well, if we look at it here, hydrogen one time was 91, but it decreased to 86. Okay? So you can see that there was a decrease of hydrogen gas. It didn't turn into anything else. It didn't convert. It just went down in numbers. Okay? D, the amount of elements in stars increase as the star ages. Did the other elements increase or did they stay the same? You see 1 and 1, so they stay the same. Our best answer in number 14 is C. The hydrogen gas decreased. We went from 91 to 86. Okay, there's no changing. You cannot change and convert into another type of element out here. Number 15. When does an object transmit light? Okay, so your key word here is you got to figure out what transmitting is. And I'm going to use an example here as I wrote down a transmitter radio. If you use a transmitter radio, somebody is communicating through the radio and it passes it through the wire to somebody else. And the word transmit means that you're passing it along to something else, moving it from one place to the other. So when I pick up the radio and I talk and it goes through the wire and it gives to somebody else, it is passing the information. So when you look at the word transmit, you're looking for passing it through the wire. It's not bending. It's not when the light stays in the object. No, when the light passes. So D is my better answer because we're passing the information. Okay. All right. We've done numbers 11 through 15.